Let's solve some log equations on page 75. So I have natural log of 4 minus 2x equals 7. Now, in order to get these log argument out, we need to rewrite it in exponential form. Okay, so look, what is ln? Well, ln means log base e of everything the same. So I just rewrote ln as log base e. Okay, kind of unnecessary, but I like to do this because I want to talk about like how to rewrite this in exponential form. What is the base of this exponential logarithmic equation? What's the base? Base is e, right? So what you do is you write e as the base. Okay, you write e as the base of an exponential equation. What's the exponent? Exponent is on the other side of this log equation, okay, which is 7. And you set that equal to the log argument of 4 minus 2x. That comes straight down, okay? 4 minus 2x. So now I'm done rewriting this in exponential form. I'm going to solve it, okay? So here, the 4 is positive, right? You see 4 is a positive 4. So you want to subtract 4 from both sides. Minus 4, minus 4. So the left side will be e to the 7th minus 4. I can't really subtract because this is an exponential term, and that's just a number. So just write it as e to the 7th minus 4. And that equals what comes down? This 2x, which is negative. Now, what's the last thing we should do? We should divide both sides by negative 2. So we found the answer already. X is this. That is going to be the exact answer, but they want you to round this to 3 decimal places. So let's get our calculator open and let's type that in, okay? So I'm doing a fraction where we have e to the 7th minus 4 on top and negative 2 in the denominator. So the answer is negative 546 and they want 3 decimal places. So I'm going to look at these 4 and I decide, I better round that up because 5 is bigger than or equal to 5. In that case, you have to round up, right? So 317th. Okay, so that's how you can find the answer rounded to the 3 decimal places. Let's solve another log equation here, okay? So before I can actually rewrite this in exponential form, I need to cancel out some things here. Like first, subtract 2 from both sides. So that 2 in front of it is gone. Okay, so 2's gone. So what comes down? I have 3 natural log of x minus 1. And that equals 8 minus 2, 6. Now what's next? I will divide both sides by 3 now to get rid of this 3. Okay, so this 3 is gone and I just have natural log of x minus 1 equals 2. All right, it's time for me to write this in exponential form. What is the base if it's natural log? Okay, ln. Well, the base is e. Okay, e is getting raised to the what power? Second power, and this equals the argument of x minus 1. Okay, so if I want to solve this for x, the last thing I need to do is add 1 to both sides. So here's my x. X is equal to e squared plus 1. But if they want decimal approximation, we just have to plug this into the calculator. Okay, so e squared plus 1. The answer is 8.389. Okay, so pre-calculus topics, you guys learn how to solve log equations in Math 161, but this section is a great review section of these skills. Okay, all right, let's look at this very last problem. Growth of an account. Marissa invests $12,000 in an account that earns 2.8% annual interest compounded continuously. Whenever you see this sentence or phrase compounded continuously, you should write down the formula A equals PERT. That is the equation for compounded continuously. Now, they're asking, when will Marissa's account double in value? Okay, now look, she had how much money in the beginning? $12,000 in the beginning. That's her principal. So you'll put that as P. But what is going to be A value, like the ending amount, if she wants to double that? Well, that's got to be 24,000, right? Now let's see what else we can plug into the other side. So we know we have to keep that E, but rate, yeah, they gave that to us as 2.8%, which in decimal, 0.028, but we do not know how long that will take. So you put T there. In the next page, I will show you the doubling time formula, okay? But let's try to solve this for once, okay? Let's divide both sides by $12,000. If you divide 24,000 by 12,000, you will get 2. Because that's how we got 24,000. We doubled it, right? So what's left on the right side? This exponential term, okay? Oh, where did that go? Let me pull up my screen one more time, okay? And now, we need to bring that t down. That's in the exponent. So what do? Remember, we're going to take natural log of both sides. Take natural log of 2. Take natural of the right side. But what will happen now is this. Will come down to the front. Okay? This exponent will come down to the front. And natural log of e, what's ln e? Well, this is just 1. So you can think of that as just canceling out. So what's left? We have natural log of 2 left on the left side, and we have 0.028t on the right side. Last thing is to divide both sides by this decimal, okay? 0.028, 0.028. So t is this. That's how long it will take her investment to double. We will have to give them a decimal answer though, okay? So type that in. So do ln2 divided by 0.028. That comes out to be T is approximately 24.76 years. It's going to take about 25 years for this investment to double. Now look, here's the formula for doubling time, okay? You can find doubling time T by doing natural log of 2 divided by rate, okay? Anytime you want to find the doubling time, do natural log of 2 divided by that rate, okay? If you want to find tripling time, you will just do natural log of 3 and divide it by rate. And this is the formula you can use from now on. If you ever run into a problem about doubling time, that's what you will be able to do.